Beyond its planetary stature and place within the solar system, our understanding of Jupiter is cloaked by the very thing that defines the planet's appearance: its turbulent and dynamic clouds. As such, Jupiter stands not just as a colossal planet, but as a majestic enigma of the outer solar system. With its giant red spot and the interplay of light and dark banding dominating its atmospheric characteristics, Jupiter's visible outer appearance is driven by its inner workings that to this day defies easy comprehension. So what is going on inside Jupiter that drives the atmosphere to give us the distinctive banding and the great red spot we see? Devoid of a solid surface that traditionally defines a planet's boundary, scientists turn to a crucial reference point on Jupiter as a substitute for its surface. This point is where atmospheric pressure equals 1 bar, mirroring Earth's surface pressure. And as a benchmark, it serves as the surface when discussing Jupiter's vast and dynamic atmosphere. Comprising primarily of 90% hydrogen and 10% helium, with trace elements of methane, water vapor, ammonia, and other materials, Jupiter's atmosphere is a complex interplay of composition, temperature, and pressure gradients above and below its surface. Descending below the cloud tops, a fascinating shift occurs when pressure builds and temperature increases, such that deep within the planet, temperatures reach an astonishing 33,000 degrees Celsius, with pressures increasing to 100 megabars. And so at this distance from the Sun, Jupiter emits more energy than it receives from the Sun. Contrasting this to Earth, where we are more reliant on the Sun's radiant energy heating up the atmosphere than its core, atmospheric weather systems form as a result, with cyclones and anticyclones spreading out across the planet. Jupiter, though, through its internal heating energy source, heats the atmosphere on a colossal scale, with heat energy ascending within Jupiter's atmosphere through massive upwelling of gaseous material, which when they reach the defined surface of Jupiter at 1 bar, form intricate bands with various cyclone and anticyclones visible on its surface. These distinctive features, visible with small Earth-based telescopes, are characterized by alternating light and dark horizontal stripes. Powerful east and west blowing jet streams bound them on either side, separating them out into these distinctive horizontal bands. Bands that have shapes and structures within them, whose dynamic and changing movements churn on a daily basis from the gaseous upwellings within the planet, and are held in place by the jet streams to give them an underlying latitudinal pattern that has been stable for decades. These lighter bands, named zones, boast anticyclonic air circulation moving in the direction to the planet's rotation, creating expansive areas of heightened air pressure. As warm air rises from deep within the planet, it cools, forming high-altitude white ammonia ice clouds, which hide the deeper and more vivid cloud layers beneath. Conversely, the darker bands, referred to as belts, experience cyclonic air circulation. In these regions, the sinking cool gas results in less dense white ammonia ice clouds, offering a clearer view into Jupiter's atmospheric depths. This intricate cloud deck reveals compositions, including ammonia sulfide, ammonium hydrogen sulfide, and a complex mix of organic compounds, where the mixing of these chemicals potentially contribute to the distinctive brownish hues observed in the belts, enriching Jupiter's distinctive atmospheric features, including the Great Red Spot, Jupiter's most iconic feature. Cyclones and anticyclones on Earth may look impressive when viewed from space, but they pale into insignificance to the colossal anticyclonic structure that is the Great Red Spot. With its super hurricane force winds reaching 250 miles per hour at its boundary, a size that is 1.3 times that of the entire planet Earth, a certain perspective on the colossal nature of this storm emerges. Discovered in the 17th century, it has remained a mystery since, with scientists positing various hypotheses to unravel its remarkable longevity. One conjecture suggests that the storm is ensnared between two opposing jet streams, generating a perpetual spin that sustains the Great Red Spot's existence, whilst another theory revolves around the vertical movement of heat and cold within the storm, proposing that this dynamic movement contributes to its enduring nature. On Earth, the energy of icyclones and anticyclones is dissipated by the frictional forces generated at the planet's surface. But with no surface and therefore no friction, there is nothing to impede the storm's momentum around Jupiter. Whatever the reason for the Great Red Spot's longevity, each hypothesis underscores the complexities of Jupiter's atmospheric dynamics and the intriguing forces that have kept the Great Red Spot raging across Jupiter for centuries. But there is also possibly another reason for the planet's atmospheric dynamics: the magnetosphere. Deep within Jupiter, under extreme pressures, hydrogen undergoes a transformation into a metallic state. Acting more like a metal than a gas in this state, it turns into an excellent conductor of electricity. And with Jupiter's rapid 10-hour day, the rotation drives a process known as metallic hydrogen dynamo that gives rise to a potent magnetic field that extends far beyond the planet, forming the magnetosphere. This magnetosphere contributes to heating Jupiter's upper atmosphere, whilst generating electrical currents along magnetic lines. These currents play a role in potentially shaping the strong jet streams within the atmosphere that play a crucial part in forming the distinct bands observed in the planet's atmosphere. Additionally, the stability of Jupiter's Great Red Spot seems to be influenced by the planet's magnetic field, with the storm ensnared between two opposing jet streams associated with the magnetic field, creating a stable environment that allows the Great Red Spot to endure over time. In exploring Jupiter's mysteries, we find a myriad of forces from internal heating, intricate atmospheric dynamics, and the influence of its colossal magnetic field coming together to create the dynamic spectacle and splendor that is Jupiter.